Cap 696. This has a list of effective pages and 4 main sections, which are General Notes, Section 2 on the single-engine piston aircraft, Section 3 on the multi-engine piston, and Section 4 on the medium-range twin-jet. Crew and passenger mass values. In determining the dry operating mass of an aeroplane, it's common practice to use standard mass values for crew. These values are flight crew 85 kilograms, cabin crew 75 kilograms. These are inclusive of a hand baggage allowance. The mass for individual passengers to be carried on aircraft may be determined from a verbal statement by or on behalf of the passengers if the number of passenger seats available is less than 10. Standard mass values. Mass values for passengers, 20 passenger seats or more. There's a split with males and females, all flights except holiday charters of 88 and 70 kilograms, or with 30 passenger seats or more, all adult is 84 kilograms. There are different values for holiday charters and children. The mass values for passengers with 19 passenger seats or less are different. Males with 1 to 5 passenger seats up to 10 to 19 passenger seats varies from 104 to 92 kilograms, with females being 86 to 74 kilograms. Children are 35 kilograms. The mass values for baggage, 20 passenger seats or more, are for domestic flights 11, within the European region 13, intercontinental 15, and all other 13 kilograms. The single engine piston. The datum is 39 inches forward of the firewall. The forward limits are 74 to 80.4 inches after the datum, and the aft limit is 87 inches after the datum. The nose wheel is 3.1 inches after datum, and the main wheels are 97.0 inches after datum. There are 3 baggage zones, A, B and C, with arms which are 108, 150 and 180 inches. There's 3 configurations where seating may be removed to allow more baggage space. Single engine piston, useful mass and moments of usable fuel. This table may be used to calculate the moment for different masses or volumes of fuel. For example, 30 gallons weighs 180 pounds, and moment divided by 100 is 112.5 inch-pounds. The fuel tank centroid is 75 inches after datum. The reference datum for the single engine piston is 39 inches forward of the firewall. The centre of gravity limits are 74 to 80.4 inches aft, and the aft limit is 87.7 inches aft. The maximum structural takeoff mass is 3,650 pounds, and the maximum structural landing mass is also 3,650 pounds. Basic empty mass is 2,415 pounds, and the basic empty mass CG location is 77.7 inches. This results in a basic empty mass moment divided by 100 of 1,876.46 inch-pounds. Landing gear retraction extension does not significantly affect the CG position. The floor structure load limit is 50 pounds per square foot between the front and rear spars, which includes baggage zone A. It's 100 pounds per square foot elsewhere, baggage zones B and C. This is a loading sheet for the single engine piston. Mass for the basic empty condition can be added, any front seat occupants, third and fourth seat passengers, baggage zone A, fifth seat passengers, baggage zone B and baggage zone C if occupied. These can be multiplied by the respective arms to gain the moment, and totals may be calculated to calculate the zero fuel mass. Fuel is then entered at fuel loading, which results in a ramp mass, and subtract the fuel for start, taxi and run up, which is normally an average entry of 10 in the column headed moment divided by 100, 13 pounds of mass, and this will give the takeoff mass. Subtract the trip fuel, and this will result in the landing mass and enable a calculation of the landing CG. The centre of gravity positions for zero fuel mass, takeoff mass and landing mass can be added to this graph, and it's important that they remain within the limits of the envelope. Multi-engine piston. This has a datum which is 25.3 inches forward of the nose wheel. Everything else is referenced from the datum. For example, the basic empty mass CG arm is 88.5 inches. The forward limit is 82.0 inches. The aft limit is 94.6 inches. And the position of the main wheels is 109.8 inches. The reference datum is 78.4 inches forward of the wing leading edge at the inboard edge of the inboard fuel tank. The CG limits at the forward position are 82.0 inches to 90.8 inches subject to aeroplane mass, and the aft limit is 94.6 inches. The maximum structural takeoff mass is 4,750 pounds, and the maximum structural landing mass is lower at 4,513 pounds. The maximum zero fuel mass is 4,470 pounds, and the basic empty mass is 3,210 pounds, with a CG location at 88.5 inches. This results in a basic empty mass moment divided by 100 of 2,840.9 inch-pounds. Gear retraction extension does not significantly affect CG position. Structural floor loading limit is 120 pounds per square foot. Here's an example of masses entered into a loading table. From this, the zero fuel mass can be calculated, the ramp mass, the takeoff mass, and the landing mass, and the corresponding CG positions. These corresponding CG positions can be plotted onto a CG location aircraft mass envelope, ensuring that they remain within limits. Here's a blank example which enables values to be added for pilot and front passenger and baggage, fuel, etc. And also a blank CG location aircraft mass envelope for the CG positions to be plotted. This is the load and trim sheet for the MRJ-T1. On the left hand side, values are added for masses and then added or subtracted depending on fuel, passengers and baggage carried. This results in values like total traffic load, the actual zero fuel mass, the actual takeoff mass and the actual landing mass, which must be less than the structural maximum. Last minute changes can be easily added to the load trim sheet. On the right hand side of the load trim sheet is something similar to the CG envelope seen for light aircraft. At the top, you start with the dry operating index, which is usually given, and then work your way through a series of rows, adding and subtracting masses as passengers are added, and eventually fuel is added at different locations in the aircraft. At the bottom of these rows, the line coming out then enters the CG envelope, and cross-referencing with the actual zero fuel mass, the actual takeoff mass, and the actual landing mass enables the CG limits and positions to be determined to be within a safe area.